Most people see broken computer boards as worthless waste, but here, every tiny connector could hide real value.
In this dusty Pakistani workshop, the journey begins with green circuit boards, fire, metal, and patience.
The gold is not obvious, and it never appears like magic. It has to be found piece by piece. The worker studies every socket, every pin, and every golden edge before the real work starts.
The secret is not one machine. It is knowing exactly which parts matter and which parts do not.
Today, old motherboards will pass through the hands of skilled recyclers in a traditional workshop.
By the end, only a small amount of gold will remain, but every gram tells a story of labor.
Before the workshop begins, the material must be found in the crowded electronics markets.
The buyer does not look for beauty. He looks for connectors, dense boards, and heavy components.
Some boards are nearly empty, while others are packed with small parts that are worth saving. Every purchase is a gamble, because the value is hidden beneath dust and damage. Experienced workers can judge a board quickly by its color, weight, and connector layout. The best pieces are separated early, while low-value scrap is packed away for other recycling. By noon, the worker has filled sacks with server boards, old RAM sticks, and damaged computer parts. Nothing looks premium here, but this market is the starting point for the entire recovery process.
The workshop depends on this steady stream of forgotten machines. When the sacks arrive at the workshop, the first job is to unload without mixing the material.
The team spreads the boards out so every piece can be seen before processing begins.
Inventory matters because different boards must travel through different stages.
The workers separate server boards, desktop boards, RAM sticks cards, and connectors. This early order prevents valuable pieces from disappearing into general scrap.
Dust is brushed away, broken plastic is removed, and the most promising boards are marked by hand.
The process looks simple, but one wrong pile can waste hours of work later.
Each container now has a purpose: gold-plated edges, copper-rich boards, pins, chips, and low-value waste. The workshop becomes a map of materials, with every tray pointing toward a different outcome. Only after this slow inventory can the real extraction journey begin.
Sorting is the first real skill, because gold is not spread evenly across the board. The worker searches for contact points, edge fingers, sockets, and dense connector areas. Desktop boards, server boards, and expansion cards are separated into clean working piles. The assistant checks damaged boards again to make sure no valuable connector is missed. A trained eye can spot a useful section in seconds, even under dust and broken plastic. The low-value pieces are not thrown away. They are simply sent to a different recycling path. The golden traces are tiny, but the worker knows exactly where to look. The camera stays close as the boards become categories instead of chaos.
By the end of sorting, the real treasure zones are visible.
Now the worker identifies the parts most likely to contain precious metal plating. Gold fingers, connector pins, CPU sockets, and certain contact pads are placed in separate trays.
The technique begins with recognition, not with fire or force. Small parts are lifted carefully because their value can be lost in the dust.
The worker compares old board types to decide which sections deserve extra attention.
A bright lamp reveals the thin golden surfaces that ordinary eyes might ignore.
Every selected part is small,
but together they create the highest value fraction of the batch. This stage turns a pile of confusing electronics into a clear recovery plan. The assistant labels the trays by material type, keeping the workflow clean and controlled. The workshop is now ready to remove the valuable sections. The boards move to the disassembly bench, where hand tools do most of the work. Screws, brackets, heat sinks, and plastic covers are removed before any cutting starts. The worker uses controlled pressure to avoid scattering small pins across the table. Every removed part is placed into a tray instead of being dropped onto the floor. This careful rhythm is slower than crushing everything, but it protects the valuable pieces. The assistant collects aluminum heat sinks, copper coils, and steel brackets for separate recycling. The table gradually fills with clean board sections and sorted components. Nothing dramatic happens for a moment, but this quiet work decides the final result. The best recyclers are patient, because patience prevents loss. When the boards are stripped down, the gold-plated zones are ready for precision cutting. The cutting station focuses on the golden edges found on ram sticks and expansion cards. The worker positions each board so the blade removes only the useful contact strip. Thin golden fingers fall into a clean metal tray with a sharp clicking sound. The camera moves close enough to show the exact line where green fiberglass meets gold plating. The assistant brushes dust away before it can cover the valuable strips. The worker checks every piece under the light, keeping only the cleanest sections in this tray. The gold fingers are one of the most satisfying parts of the entire process. They look like tiny scraps, but they are the workshop's most prized fraction. Next, the team removes connector pins from sockets, ports, and old communication boards. These pieces are small, sharp, and easy to lose, so the work happens over a catch tray. The worker bends plastic housings open and shakes loose rows of metal pins. Some pins are gold-plated, while others are copper, tin, or low-value metal. A magnet, a sieve, and visual inspection help separate obvious non-precious pieces at a high level. The camera follows the pins as they fall like metallic seeds into the tray.
The assistant keeps the work surface clean because dust can hide the smallest valuable particles.
This part of the process rewards accuracy more than speed. A few grams here and a few grams there slowly build the recoverable material. By the end, the connector tray is ready for controlled processing. The remaining boards still contain chips, capacitors, coils, and mixed metal parts. The worker removes components by category, so each material can be recycled correctly.
Large chips are lifted into one container, copper-rich parts into another, and plastic-heavy pieces aside.
The visual focus stays on organization, because mixed material lowers recovery efficiency. The assistant scrapes loose debris into a separate tray for later screening. Close-up shots reveal the texture of old solder points and cracked fiberglass.
This is the less glamorous side of the work, but it is essential. The boards slowly become cleaner, flatter, and easier to process mechanically.
Every recovered part has a next destination inside the workshop. The batch is now ready for pre-processing. The blue rotary separator takes over after the highest value sections have been removed. Only prepared board pieces go inside, never a random mix of complete electronics. The drum turns slowly, knocking loose dust, fragments, and lighter material. Flames and heat appear only as controlled workshop atmosphere, not as a magical source of gold. The machine helps break the material down so plastic, fiberglass, and metal can separate more easily. Small fragments fall into a collection tray, while larger pieces continue rotating. Smoke is pulled upward through ventilation, keeping the worker away from the hottest zone. After several passes, the material is ready for screening. The screened material is divided by size before any further recovery happens. Fine dust, small metal fragments, and larger fiberglass pieces each move into separate containers. The worker uses trays and mesh screens to classify the material without rushing. The camera captures small particles trembling across the screen as the assistant shakes it gently. Heavier pieces settle faster, while lighter waste collects on top. The workshop does not rely on one dramatic step. It relies on many small separations. The cleaner the categories become, the easier the later stages will be. A close shot shows the difference between dull dust and shiny metallic specks. The worker marks each container so nothing is confused with general scrap. The valuable fraction is now concentrated enough for safe recovery. The next stage is shown only as a safe, closed recovery process, not as a chemical recipe. The worker moves the concentrated material into a ventilated, sealed recovery area. In this controlled environment, specialized ventilation ensures the safety of the workers as the final extraction of gold takes place. The process is about controlled recovery, filtration, and patience, not shortcuts. Inside this sealed recovery unit, the pulverized materials undergo a final separation. The gold, heavy and resistant to corrosion, the sealed unit keeps the valuable fraction contained, while unwanted material is separated. Safety is paramount in this final stage. Here, the raw materials are refined, revealing the gold hidden within the circuitry. The assistant records batch labels and moves clean trays into position. The tiny gold-bearing particles are now being concentrated under controlled conditions. After the closed recovery stage, the material passes through filtering and settling trays. The worker collects residue from the bottom of a clean tray using a small scoop. Fine particles gather slowly, proving that the value is measured in patience, not spectacle. The assistant rinses the outside of containers and keeps the table organized. Macro shots reveal golden flecks mixed with darker metal dust. The worker never lets the material splash or scatter, because every tiny speck matters. The process repeats through several filters until the fraction becomes cleaner. A small glass dish catches the most promising particles under a bright inspection lamp. The pile is still small, but it is much richer than where the story began. The recovered concentrate is now ready to dry. The collected material is spread thinly on a heat-safe tray for gentle drying. Under the warm light, the particles lose moisture and become easier to inspect. The assistant checks nearby trays of copper, aluminum, and plastic to show that nothing is wasted. A macro shot shows tiny gold-colored flecks resting among darker grains.
This is the quiet pause before the fire returns.
The workshop slows down, and the sound of machines fades behind the ticking fan.
The worker uses a small brush to gather the dried concentrate into the center. Each movement is careful, because the final amount is still very small. When the concentrate is dry, it moves to the furnace corner. Once the materials are sorted, they are placed in a crucible, ready for the intense heat of the furnace. The recovered concentrate is weighed in a dish before it goes near the flame. The assistant clears the table so nothing flammable or unnecessary remains nearby. The intense heat of the furnace begins the final transformation, melting the recovered metallic flakes into pure, reusable gold. The furnace glows orange as the workshop light becomes more dramatic. This moment gives the audience the payoff they have waited for since the first board. The batch is small, but the tension feels big, because every mistake would waste the work. Inside the furnace area, the recovered material is heated under controlled workshop conditions. The worker uses tongs and a crucible, while the assistant keeps distance and watches the tools. The camera captures glow, reflection, and heat shimmers without showing unsafe close handling. After meticulous sorting and separation, the concentrated metallic flakes are melted down. Here we see the final, realistic yield from hundreds of circuit boards. A small amount of recovered metal can still feel powerful after so many hours of labor. The worker tilts the crucible carefully toward the prepared mold. The concentrated material is then subjected to high heat, allowing the precious gold to melt and be cast into a bead. The workshop falls quiet as the metal cools.
The small bead is left to cool before anyone touches it.
The worker places the mold on a clean surface and waits for the glow to fade. Once cooled, the bead is lifted with tweezers and rinsed in a safe, simple cleaning station. The assistant wipes the table and prepares a white inspection cloth. The camera moves close as the bead rolls across the cloth like a tiny sun. It is not a giant bar, and that honesty makes the result feel real. After careful refining, the precious metal is ready for inspection, a stark contrast to the discarded electronics it came from. The scale difference tells the entire story without needing exaggeration. A final polish reveals the warm metallic shine. The recovered piece is ready for weighing. The weighing table becomes the final stage of proof. The worker places the tiny recovered bead on a digital scale beside the stripped boards. The assistant sets out trays of copper, aluminum, pins, plastic, and fiberglass as secondary results. After weeks of meticulous sorting and separation, the precious metals are finally ready to be weighed. Every gram recovered makes a difference. The bead is small, but it represents hundreds of careful decisions. A close shot shows the worker holding it between tweezers with a quiet smile. The value of the process is spread across all recovered materials, not only the gold. The workshop has turned a pile of dead electronics into sorted resources. This is the final reveal, not fantasy gold, but real recovered value. The worker places the bead beside the first motherboard, closing the loop.
The camera now pulls back to show the wider recycling story. Copper, aluminum, steel, plastic, and boards are all organized into separate recycling streams. Gold gets attention, but the workshop survives because every material has a path. The workers sweep the floor carefully, collecting small fragments that would otherwise become pollution. The old electronics no longer look like trash. They look like a resource map. The process also shows the human labor behind every piece of recovered metal. This work is difficult, dusty, and repetitive, but it gives value to forgotten machines. The assistant stacks clean containers, while the main worker checks tomorrow's incoming batch. The story becomes bigger than one bead of gold. It becomes a story about skill, survival, and recycling. The final scenes return to the workshop floor where the journey started. The first pile of motherboards is now mostly empty, replaced by sorted trays and recovered material. The worker holds one old board in one hand and the small recovered bead in the other. In this place, value is not found by luck. It is earned through patience and knowledge. The blue separator sits silent as smoke fades into the rafters. The workshop door opens, revealing more sacks of e-waste waiting outside. One batch is finished, but the cycle continues every day. After weeks of careful work, the transformation is complete. These few grams of gold represent the hidden value in the world's electronic waste. Old technology has reached the end of one life and the beginning of another.